Hello, everybody. Welcome back. My name is Michael, and we're going to learn how to program today. Hello, welcome. Really setting the mood here today, guys. Welcome, welcome. How's it going? Wing Hong, welcome. Geodasher, how you guys doing today? We are doing good. I got that going here. Woo! All right. Nice. We'll see what that can do. Hopefully we don't burn the place down here. Alright, keep an eye on that. Hopefully it won't get too hot. Put this here. There we go. That's better. Okay. Gina! Hey Gina. How you doing? Alright, let's go. All right. We got some people rolling in here. Let's go ahead and let the Discord know that we are live today. I really appreciate you guys joining me today. We are going to have a great stream today, learning and teaching ourselves various programming concepts. We are going to be doing a lot. Today's going to be a really good stream. Going to be bouncing back and forth between a few things, and then I actually don't work tomorrow, so I can stream for quite a while tonight. There we go. All right. Hope everyone's having a great day so far. We got some people rolling in here. Wing Hong Geodasher, hello, hello, LS Dominguez. I appreciate you coming in. Awesome. Hey Adele, welcome back. Welcome back, you guys. Welcome back. Hair's kind of funky. I might need to throw on a hat today. We might need to throw on a hat because it might help also because it is a little bit chilly in here. So I might actually just go ahead and do that. They've got a beanie of choice here today. Let's go ahead and roll this guy up. It is winter time here in the Bay Area. I'm located in Bay Area, California here. Yes, it's cold winter time in the California. Oh, it is. There we go. Let's get a hat going here. I like my beanies. All right. Nice. Hair is fine. If you are liking the hair, okay. Maybe we should have kept the hair back. All right, we'll keep the hair. You guys are funny. You guys are too funny here. All right, we'll keep the hair here. All right, whatever. You guys are funny. Okay, today, I know I'm off to a slow start here, but we're getting started. Yeah, Geodash, I feel that. Beanies are my hats are my go-to, just easy to cover up the hair when it's going crazy. Definitely. All right. So, let's go ahead and back it up here. So, I think for the plan for today is, you guys, I would like to take a stab and warm up with some more linked list practice in the end of chapter 7 here. And then I would like to shift and maybe take an attempt at completing the problem set, or maybe taking a stab at the problem set for CS50X, right? So yesterday we started CS50X. I recorded that stream yesterday of us going ahead and watching the first lecture and doing a kind of a watch party. We had a lot of people. I think we got up to like almost 45 people watching all at once yesterday. So I think we broke some records on the stream yesterday. So it was super, super cool. Thank you so much to everyone that joined yesterday. Seemed to have a lot of positive feedback of people being like, yes, this is what I was looking for. I wanted to follow along with somebody in doing this. So we're going to be continuing on. Now, I will preface, I do put in a lot of time and hours into doing this and streaming, and I do this programming and stuff. So I'm probably going to work through the course. I'm not going to get ahead of myself, but I might be going through it fairly quickly. So just that's why I'm going to just you can always go back and watch the previous streams. I'm also going to be like I said, I recorded the stream from yesterday, so tonight hopefully I'm gonna chop it up. It's kind of a long stream, right? So I'm gonna chop it up, get rid of kind of the chats, reads, and stuff, and just kind of into a more condensed. This was the watch along. These are the kind of the parts you need to know from the lecture, and then we'll just kind of do like a recap, general watch video for the channel, similar to the ones I did for, or at least I started to do for CS50, but I kind of completed that on my own. CS50P rather. So for those that don't know, and that came yesterday in the beginning of my streams, or like we do live learning, and in the back of my streams we'll do project implementation and practice. So yesterday we started CS50P, but I don't do that every day. I want to kind of break it up. It's good to be excited about things, but also I don't want you guys getting bored of the same thing every single day, or yada yada yada. So I do want to jump back into and keep going though with our learning into data structures and algorithms in Python, because this is we've gone a long way. We're almost on page 300 here. We're doing the end of chapter 7, reinforcement problems. So yeah, we were learning about linked lists. Now, for those that aren't familiar with linked lists, these were a way. Now, bear with me. I'm learning these myself. These were a way to kind of categorize or handle data in a certain way using object orientation, right? Using the use of objects, items, and classes and things like that, right? We can tie these objects together by assigning the object to a next, or in some cases, in like a doubly linked list, a previous and a next value. So we can call upon various methods to these objects to shift and go into the next object in the chain, right? So it's no different than creating the object-oriented, that we've created so far, like in our small business manager project, right? So I've been kind of thinking about this offline, it's really no different than the object orientation that we've kind of already done. We created instance variables. We've assigned these instance variables to, the data that was inputted, but what's stopping us from directly assigning an object to one of these instance variables, right? That's essentially what is going on here. And so we are just creating a chain of objects that can be called upon by, instantiating some various instance variable to move down the chain. And so this gives us some benefits of, like we don't have to iterate over the course of the entire, list to perform certain actions or find them. We can, directly insert and put in items directly, like we can assign, the next item in the chain to something, or kind of split down the middle and assign directly without having to shift all subsequent positions, right? Right, we don't have leftward or rightward depending on which way you're going. So it creates this more like in the idea of what was it, stacks, decks, and queues. Like we had an overarching constant time operations happening, but we had some amortized constant time happening because we had that dynamic resizing of those arrays in our memory sequence. But this essentially houses these objects and just jumps or traverses from memory location to memory location just based off calling, various functions or instance variables methods, right, to these, objects. So general overview of what we were kind of getting into. I appreciate you guys joining me here. All right, Frost Orbs. Hey, thanks for coming in. You guys are so funny. I appreciate you guys. Motivation to Code. Hello, Christy. Welcome in. Welcome back. You guys are awesome. Thanks for coming in. All right. So we completed 7.2 last time, and now we're going to jump in and try 7.3. I want to maybe do like 2 or 3 problems, and then we can jump and try to complete the CS50X week 0 problem sets, or we can continue on maybe watching some of those the lectures, or we can do code our project wherever. I can stream for quite a while this evening, so it should be fun. If you're here with me. Feel free to leave a like on the video if you're enjoying it and follow along. I love having you guys here and talking. It's really awesome to have you. All right. Let's go ahead and get this copied in. All right, here we go. So describe a recursive algorithm that counts the number of nodes in a singly linked list. Okay. So we want to, recursively count through the algorithm, right, or through the data set or the linked list, singly linked list rather, until we reach a base case of, well, this, the base case of there's no more values at the end. There's no more next value. The next value is none. So we can create a counter and, is my internet lagging? Am I jumping all over the place? I apologize if it's glitching out here. Hey, Hysterical Mafia, thanks so much for coming in. Is my internet cutting out, Motivation? Hold on, give me a second. Okay. Okay, hold on. We good? I think it's okay. Okay, sweet. All right, I want to make sure it was good for you guys. I was trying to see if I could mess with the router down there, but I think it's okay. Okay. Sounds awesome. Okay, so similar to our previous problems that we did recursively, I think we can do a similar approach here. So I'm going to copy over. From our last problem, we created this node class to just create an actual object or a node in our singly linked list. So now we're going to make a def count nodes, and we're going to take in some initial node to start, right? So we need to take in some start node here. Oh, whoops. All right, awesome. So we're going to take in some start nodes. So this is a recursive algorithm, so we need to establish a base case. So we have a few base cases, right? What if right off the bat there is no node? So if start node.next, right, is equal to, what would it be? The start node not next is equal to none. Like right off the bat, we're going to return, right, 1, meaning that we're going to return 1, meaning that there's only one node in this singly linked list. If the start right, that would be our base case. And these other base case I did right here, so if I did the head is nud, or head, right? So I should rather use not head start node. I'll use head node. I forgot that that is the context we should probably be using, or the terminology rather. So we're going to use head node rather. So if the head node dot next, okay, that was that single one. So in this one, if the node is equal to none, meaning there is no node, right, then that's our base case as well. I forgot about that one. Whoops, open up here. There we go. No, get out of there, chapter 6. Oh, whoops, not in chapter 5 either. Jeez. All over the place. Okay, so if head node, right, equals to none, we're going to return none. Return 0, right? Return an integer. So yeah, exactly. We could do a loop until we reach the last one, right? But this one specifically is asking for a recursive algorithm, though, I believe, right? Let me go ahead and zoom in. So it's all right. return 0. So then we're going to say else, right? Our else statement, we're going to call head, we're going to call count, or we need to establish a variable such as count equals 0, or count equals 1 in this case, to account for the current node that we're on. Or no, we'll just say count equals 0 here initially, because we're going to return plus a count to return count plus equal 1 on each recursive call back. So we're going to call count nodes on the head node dot next, and for each call, right, and then we're going to return count plus equal 1. Can I not say plus? Do I have to? Can I not do this in a single return statement? Okay, we'll just do count plus equal 1 return count, I guess. Whatever. Sorry, a little rusty. I don't like how it's so zoomed in for me. Sorry, guys. I'll just increase the font. Okay. Oh, return count plus 1. Okay, that's the way to say it. Okay, so we're going to, on each in depth, we're going to return count plus 1 on each call. Now, do we have everything set up here structurally? So if the initial node that's given, the head node, first next call is equal to none, we're going to return 1. There's one node. If the initial head call is given is equal to none, meaning that this value is a disintegrated or whatever term was used node, then we're going to return 0. There is no nodes here. Else, we're going to establish some variable count. We're going to establish some variable count. So this is our base case if the head node.next return 1. So hold on, I'm going to take this guy, I'm going to move it up here, put it here. So if head, this is our base case, we're going to return 0 here, or return count. I guess I have to return 0 here. And then, right, we reach a base case. So if I return count, I have to set node count up here, right, initially. So I can return count, which is 0, but it's going to return each time at that point, right, each iteration on the else call will increase count by 1 and return count. To this value. And it keeps getting returned back. So I don't want to return count. I'm going to call count plus 1 here and return this value here. Take this, put it right above it there, and I think that'll work. So initially we get the head node, we establish a count 0. If the head node is equal to none, we're going to return 0. That this node is none, right? This node has a value of none. There is no head, there is no nodes in this, whatever. It's not an object, right? If the head node dot next is equal to a none, we reach our base case, right? Where when we finally next, this is the last value, and we're going to return count. So this count is going to be equal to 1 initially, because we're going to return count. Or we have to set count to 0 and return count plus equal 1, like that, which we probably should do here. We don't want to initially set it to 1. I mean, we could if this is initially a node, or assuming it's a node, but I think that's kind of naive to do given users, right? Just thinking of edge case things. Right. We're gonna, right, if the edge case things, like given if like a user is entering it, if we assume it's a 1, right, we could return the count right away if it's equal to none, and maybe it's not a node. So we just probably should initially assume 0 and return a count plus 1 if we actually get a next call that's acceptable to get none. Else, right, we're going to continue increasing our count until we reach I think we might get one more count than we were looking for here. We're gonna, okay, let's draw it out real quick. I think we're making this a little bit more complex than we need. People might have already caught this. I'm trying not to get things spoiled here. So we have the, let's say we're gonna count, let's say we have 3 nodes in our list. So we're gonna call count node on 3, right? This is gonna go down to count node. On this call, we're gonna increase count is equal to 1. On this call to count node 2, we're going to count is going to be increased to 2. On this call to count of a single node left is going to be increased to 1. But if it's equal to none, it's going to be, sorry. So if it's equal to 3, on the 3rd node, we're going to add count plus 1 again, right? And we're going to get, this is going to become 3. Count is equal to 3, and then we're going to go 1 deeper and try 2, and we're going to hit our base case, so we're going to return just count. We don't want to return count plus 1 on the base case. We want to return just count. I think so, right? Let me get caught up on the chat here. Sorry, guys. Tom in, thanks so much for joining. Are you going to cover the week 9? Week 9 in the CS50X course, we just started yesterday, so we're only on week 0. But we will eventually get to week 9 in due time, fairly soon probably. Maybe within this, I'm probably going to do maybe about 3 of the weeks. My goal is to do 3 weeks a week, like 3 weeks a week, or 2 to 3 weeks a week. Is it not creating a new count every time you call the function? I think you would need to be able to pass the current count into the function. I got the notes from this, but they're in C++, lol. Yeah, notes from my previous C++ class. Yeah, you're resetting count to 0 every time it gets called. Count is kind of redundant. Wait, aren't you resetting count to 0 every time? I don't want to set count the outside of the method. So on each call, So we need to return a value of count plus 1 each time. So we return the initial count to 0 to this value. Zero gets returned here. So we maybe not need a count, rather. Or maybe we do, but we say return 1, return 0. I mean, this is kind of redundant having two return zeros here, but we return 0. 0 gets returned for this value, so we want to return 1 plus this, right? And so this wouldn't even really do anything. Like that. Thank you guys for catching that. Yeah, so on each recursion call, our count is being reset. So we need to actually return the count together with the base case here. So the base case is returning 0. 0 is being returned in place of what I just highlighted. So we're going to append 1 to it and return that value each time. I think people are agreeing. We're cooking with chefing it. You guys are funny. I like you guys' terminology. You guys are funny. Yeah, a lot of these problems, Matthew, I agree with you. We definitely can set the variables outside, but like think about it from like a user standpoint. Like we don't want the user to have to like go into their program, set some variable in the code, and then have to call the function. We want the user to just be able to just apply this count nodes function directly on their data material. So to make it more universal, I'm really trying to wrap all of the kind of data associated and inside and nested in the function itself, just to create that more universal approach. But yeah, and we could pass it as well to continually count, right? So now let's give a let's go ahead and get our nodes here. Boom. So this was just an example of a linked list I created last time we practiced this. So node 1 is next to, node 2 is the next value of node 1, node 3 is the next value of node 2, node 4 is the next value of node 3, and node 5 is the next value of node 4. So we're going to call, right, print count nodes on n_1, the head node, right? And fingers crossed, we should get 5 here, you guys. Come on, come on. 4, no! Dang it. Got 4. Well, we have 4 next calls. So it's counting the amount of next calls. So I think it's not initially counting your head node. I think that's what's going on, right? I think it's counting, just off of how I'm looking here, it's counting the number of next calls because of our base case. That's what we're really tracking, right? So we need to return 1 here. And now we'll get our value. Dang it, I'm pissed that we didn't get that. I mean, we got it right, but I'm pissed that we didn't see that ahead of time. Ah! Come on! It's all right. All right, we got this candle going. Oh, we lost a flame here. Hold on. don't know if YouTube will like mark this as if I put a lighter in the video. So let's just light it off camera. Come on. No, it's not working for me here. It does not want to stay. There we go. All right, there we go. Got it. No. I think it's because it's on a slope on that thing. Oh, shoot. We're getting distracted, you guys. Sorry. We need a single flame candle. All right, let there be light. Aha. On the books. No. I like that little view there. Nice. All right, we gotta be careful. Okay. Cool. All right. Cool. We got a little candle set up. Nice. We got the lava lamp going. Woo! Let's shake up the lava lamp a little bit. Get that going. All about getting that mood going. Nice. Okay, cool. Let's get that up against the wall. This is red mandarin guava this evening. Thanks for joining me, you guys. I appreciate you coming and learning with me this evening. I don't have work tomorrow. For those that are new here, my name is Michael. I graduated back in 2021 with a degree in human biology and a minor in chemistry from Utah State University here in the United States. I went there. I'm from Oregon initially. I went there. I had some family connections. My mom, played some sports there, and it was a good deal. And I enjoyed the school, my time there, and I enjoyed the kind of the biology department is where I kind of really zoned in on, and the chemistry department especially. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for the past 3 years. I got a job right out of college in 2021, 2022 as a formulation chemist for a biotech company where I make biological controls, and I've been teaching myself Python after my 9-to-5 job and on weekends for the past about 6 months. So it's been really cool, and I made this stream to kind of document my progress and create demonstrate this from a beginner's point of view, someone that's never really programmed before, and show what it's really like to program from a starting from nothing as like I guess a 25-year-old guy. I often found that people were kind of, there's a facade on people learning to program. They like, oh, I learned how to do it in 3 months and I got a job, yada yada. I became a master in this amount of time, and it really just didn't seem very genuine to me. So I wanted to kind of break that down and provide a authentic approach to this and what it would kind of take to, for a normal person like myself, to kind of do it. So I really appreciate you guys joining me here. All right. LS Dominguez, why did you set a default parameter to none in the function? I mean, I return none because there are none, or I guess I could return 0, right? I probably could return 0. Either way, if I'm going to return an int, the function's job is to return an int in terms of its makeup. Like if I did this, and make this a what would this have to be, like a class? But you can't put that in there. You have to make it like a object, but like that, right? I guess object works. So you provide an object and then you get an integer back, so you'd have to return 0 then. But I mean, if there was none, if the node is none, you could just return none. Or but this, I guess you'd probably write 0. All right. Hysterical Mafia says, it has such a nice background. Meanwhile, I'm sitting in the dark like a gremlin. Well, as long as you're here with me, we have a nice ambiance set here. I know my screen is a little bit small, so it's not. If it was big on the screen, it might be a little bit better. But thanks nonetheless for being here. Hey Neil, welcome. Appreciate you joining. Awesome to hear from you. All right. Yeah, statistical would specify the return value as an integer-based type here. So yeah, we will return none. Awesome. I mean, sorry, 0. All right, return 0. Let's keep moving here. We solved that one pretty quick. Any more questions on what we did here, you guys? You guys anyone want me to break this down? So we are, for those that are new here at the beginning, we have been reading for the past couple weeks. We're on page 294. We've been reading word for word, line by line, example by example, really breaking this down. I'm not in any rush to complete and rush through these things. I don't have a professor or a test at the end of the semester. I am my own professor. I am my own. Yeah, I'm cracking the whip on myself. So I want to learn all this stuff, and so I'm taking my time through this, breaking it down, making sure I have good examples and good notes and everything. And then, so if you want access to my notes, it's all on my GitHub and shared, or you can join my Discord link below, where I provide all my PDFs for the link for the files I'm using, for the courses I'm taking, and all the inside information regarding those things. Yeah, we've been reading this, and we're doing some practice problems at the end of chapter 7 that we finished a couple streams ago, and I am using CS50X to also help break things up. All right, let's see what the output is here. 5, and let's put in some object of n. Let's say n equals a none type, right? We put in that. You get 0. Perfect. Now if I put in n underscore 1 and I delete the 5th node, and I right, I get 4. Cool. Everything works appropriately. Nice. All right, let's go ahead and also make my, I think that's fine. Let's keep going here. Anyone want me to break this down before we move on? Leon asks, do you need the dot next since you already have the head dot underscore node is equal to none? I'm assuming you mean right here in our base case. We don't, this is not our base case. This is an edge case, right? Right? This is an edge case where the user puts in a variable or a value that isn't, right. So if you already have, it's equal to none. So my understanding, I'm not sure, but I think no, I think we have to have this. No, we don't want you guys. I think we're kind of getting right. We have to have this part because we want to check that we're on our last node, right? We're not checking if the node is none. This is just an edge case to determine if the user inputted a value here that is none for a node, then it would be 0. Think about what happens if you remove it. So we return 0. Oh, I guess that is true, right? if you return this, because you're continually calling next, you'll return 0 on one step further. But we wouldn't technically, I don't think, want to do that because that would call for one more depth of recursion to be called. And so it might be more efficient to just have this and keep an edge case as a checker, to not have one more depth of recursion called for. But in this case, it's so small, I don't think it really, we're not doing too much data processing here, so it doesn't really matter. But it would just be another level of recursion, right? Yeah, so it would give us the same answer, 5, but it's doing one more step of recursion to reach an even further base case of head node equals 0, rather than just doing a check on if the next node is equal to none. So in terms of efficiency, I'm not sure if anyone wants to chime in. This would be a good check here just to do that, but this would just be a better stopping point. It's one more recursion depth, but one less if statement. What would be the cost of the if statement check versus the recursion depth? That is the question then. Interesting. Awesome. That's really helpful, you guys. What is the cost? Well, if statements just do a constant time operation, so the recursion depth, I think, would be slower, right? If additional recursion rather than an additional if statement. The cost difference between an actual additional recursion and an additional if statement depends on several factors, including computational context. Yeah. A single if statement is constant time memory usage. So it adds another recursive call. The difference is the stack depth, so I think technically the extra level puts more into memory, yeah. So in terms of efficiency, I think that this one would technically be more efficient, but we could comment this out and just get rid of that as well and give us the same answer. But, I mean, this is a pretty small, I mean, if this was thousands of nodes long, then I think it might matter, right? But it's just one more depth. I'm not sure. But what do you guys think? Thank you. All right, let's move on. R7.4 underscore key dot pi. Okay. Describe in detail how to swap two nodes x and y, and not just their components, in a singly linked list given references only to x and y. Repeat this exercise for the case when L is a doubly linked list. Which algorithm takes more time? Okay. So let's go back up to our previous function and pull in some information here. We need to create a node class, right? We need to create a singly linked list. So this is a node for singly linked node. So this is right. And then let's go ahead and say, in order to swap nodes, so def swap nodes, node 1, node 2, right? Singly swap nodes. Okay, singly swap nodes. Node 1 and node 2. So we need to say, given node 1 and node 2, we need to do a setting of the we need to do a setting of the so it doesn't really say that the node is ahead of one or the other. It just says to swap them at any point. So we just need to say pre-save their next variables and then override them, basically. Right? So we can say we need to save node 1 dot next is equal to we'll say temp is equal to this, just to, for might be better descriptive, but temp is equal to that, a temporary variable, node 1 dot next, right? We need to set let me turn off my heater real quick. So we need to take the node, take node 2, and put it in its place, thus receiving the next call of the previous value of node 1. So we need to find the previous value of node 1, because then we need to assign the previous value of node 1 next to node 2. So that's the whole point, is to try to compare doubly and singly linked lists here. So I think we're on the right track. So we need to first traverse down the while not. So we need to take node 1. We need to find the previous value. But we don't know if node 1 is the starting value or not. So that's the case, is we don't know if it's the head. Or if either of these come prior to one another. I mean, they're technically, each node can be a head if it has another value associated with it, right? But, So let's say we have value A, B, C, and none. Right? This is our singly linked list. We want to take given value, given function, swap singly linked nodes of B and C. We want to produce a singly linked list of A, B, C, and B. So if we were to take B, traverse down until we find either the end or the other node, we can set the other node equal to B's placeholder positionally, and then we can assign B to C from there. You also have to change the next variable of the node that points to each of them. Yeah, the ones before, exactly. So we either given, so that my dilemma is we don't know if either of these nodes is the head node. So if we're given a node that's in the middle, we either can traverse down until we find the given node here, save its previous value, set B to what its previous value is, and then set C equal to B. I think that's what we have to do. So how would we have to do that? So while we can iteratively do this, while node 1, right? While node 1 does not equal to node 2, node 1 dot next. So while node 1 dot next is not equal to node 2, so what this is going to do is it's going to take node 1, which will be B in this case. I'm gonna get another example. We need a couple more nodes here. So let's say we have A, we have B, we have C, and we have D, and we have none, right? Right. So if we're wanting to swap nodes B and D, right? So if we call singly swap nodes, or that's a W, nodes on B and D, what do we need to do? We need to take B, start at B, right? Start here, and then traverse down while B does not equal to the next of node 2, D. So it'll get to C here in our while loop, and it will try to do node 1. Will this continually call next on specifically node 1? Right, so in our while loop, right, my question is, guys, is this going to do just one next value? Or one next, function? Like, what if it needs to continue going down? Right. So I'm what do you guys think? So my question is hello Harry, welcome in. I appreciate you coming in. Yeah, I'll have to keep exactly. So that's what I was getting to, is that we're gonna have, thank you so much, Jake, is we're gonna have to keep track of a new variable, and then set the variable So while start, while, what's a good descriptor for this? While current node does not equal to node 2, we're going to when we first call this function, we need to set node 1 equal to current node. Right, and then while current node does not this, and then we're going to call current node dot set current node dot to current node dot next. Exactly. Okay. So while current node does not equal to node 2, so this is going to get to that node then. So B will get to C. Okay, it does not equal to this one. I don't want it to stop though on our value. I want it to stop one prior, so I can set the one prior dot next value to B and then save B to that value. So while current node dot next, that's what we're going to have to do, I guess. While the current node dot next does not equal to the node 2. So now we're going to stop on node C here. Right? And we will evaluate, okay, the next value is the node 2, so what do we need to do if it is? While it's not equal to, we're going to continually set current node equals to current node dot next, and then continue this loop. Once we break out of this loop, we're at this point where we are at value C now for our current node. Right? So C now is our current node in this example. Sorry, I'm talking a lot. Appreciate you guys following along with me here. So C is our current node in this example. We need to now save the node 1 we need to save the node, right, or we have the node 2 here. So we have them pre-saved already up here. So we have them pre-saved already, so we don't need to save them again in our function somewhere. That would be repetitive in my opinion, I think, right? So we need to have set the value. We do need to save one of these somewhere though, I think, preemptively, because we're going to override and we have to save it. So I'm going to say node 1. So we save the start node outside, and then we say we're going to override the value oh, this is getting tricky. So if we save C.next to B, D is now gone. But it's still in our function as node 2. we just need to save current node dot next is equal to, I guess we'd have to call this over here, node 2 is equal to current node dot next. So now we set, no, we'd have to set start node, right, equal to current node dot next. Now that is overrode. So current node dot next, start node, oh. And then we set node 1 is equal to node 2. Okay, let's think about this. So we're calling singly swap nodes B and D. Okay, so we're going to set initially, B is set to here as start node. We are then going to save a value of current node as the start node as well. I'm not even think we need start node here. So then this becomes just node 1. Node 1 becomes like that. Okay, so now what we're doing is we are going to traverse down the singly linked list until we reach a point where the current node's next value is equal to node 2, right? So we're calling current node is equal to current node dot next and continuing, right? So we're starting on A, right? We're starting on A. Okay, or no, we're not starting on A. We're starting on B. B is what's given here. Okay, we are going to traverse down until we got to C. Okay, C. Okay, B. Okay, so hold on. Our first call says current node dot next is not equal to node 2. Our B dot next is C. That does not equal to D, so we're going to move one down. Boom. Okay. Now we're going to call this again. Our current node, which is C, dot next, does not equal D. Oh, well, it does in this case because node 2 is D, and that's what's given. So now we're going to stop on this value and break out. Right? We're going to break out of this loop. This condition is not met anymore. So we are then going to set node 1's value. We're going to set B. We're going to set B to D. And then we're going to take D, saved already in the parameter up here, and save it as D here. Is this correct? I'm not sure. Let's find out. And then we're going to return. So what do we return here though? Just nothing? It just does something? Applies it to the current. not the other way around. Okay, so how would we go ahead and test this? So we need to, hey, welcome in. I appreciate you guys joining. Uh, it's kind of a Abdullah. Thank you so much for coming in. I appreciate you. Welcome, welcome. We're just doing some data structures and algorithms in Python right now. Before we go ahead and jump into CS50X as warm up, we want to swap two nodes in a singly linked list right now. We're on problem 7.4. So I'm trying to figure out how to test this. So we have our nodes established. We're going to swap nodes 2 and 3. And then print it before and after, right? So in order to do this print, we do this one while this little guy here. So while what did I say? While new L combines and this returns each value. Okay, so you guess you can say while each value. So while underscore 1 print and then do n underscore. Like that. Okay, so we'll need to print these now, and then we'll call a singly swap nodes on N2 and N4. Okay, and then we're going to call this one more time. So now, fingers crossed, let's see what happens. I'm not sure if this is going to be best. Okay, so we got something here. I'm not sure. Uh-oh. All right. Okay, we got one call here. What? You might want to wrap that function in that while loop in a function. You need to call the function twice. I think you created an infinite looping list. So this printed our first one. There's nothing else to print after line 47. Oh. I'm overwriting N1. Oh, okay, so we'll go like this. Sorry. We don't want to use that. There we go. We'll take print n.data n1.next. Oh wait, we'll have to do this twice actually. Hold on. Or create a function, right? Like you said. So we'll say def print print singly linked list head while ahead. While head, we want to print head.data, and then call head equals to head.next. Okay, and so then we're going to remove this and call print a singly linked list on N1. We are then going to call this function on it and then print it one more time. Is that, I mean, is this any different than what we did before? So this isn't returning anything. It's not a method being applied. I need to, I'm not actually changing anything here. I need to return but I don't know what's the actual head node. And it might seem weird because I'm using head here, but I don't. Yeah, I think it's our function here. So we're actually not overriding anything on this method, right? It's we need to return something to this method or from this method. But if we can't return the head node because then we might not know the preceding nodes from the ones given, right? If raise, what do you do for the value error? Is like raise value error as E. How do you do this? I've never actually raise value as. No, it's not as. Raise error as E. No, what is it? So if it actually never gets, if it never meets anything, right? If the current value, once we break out of this loop, right, continues, it goes until so while the current next is not equal to none, we're going to do this. We need this to happen inside of this check to happen inside of our while loop though. So say if the current node dot next is equal to none, we got a base case, we want to return none, right? Just for temp. No, no worries. If you, I like your guys' help for sure. Okay, so right, we have another case here, right? While the current node dot next is not equal to, we're going to set current node is equal to this above here and say if current node dot next is equal to none, we're going to return none, none found, right? Else we're going to continue this statement. If the current node dot net, no, that's not right. So then we're going to set node 1 is equal to the current node dot next. And node 2 I mean, this doesn't change anything with our function either. Everything's still the same. So what is not happening in our overrides here? We need to modify the previous values dot next to be, right? That's what's happening. Is that next value. So we're creating two separate linked lists in memory technically. One smaller value than the next in this specific example. Pro Doc, no, we have not yet. We're warming up with this one right now. We've done a couple of problems here so far in DSA, but I'm going to be streaming for quite a while this evening, and I'm going to be recording when I do the work on the CS50X course so I can upload that to the channel. Whoa, crazy here. But yeah, so I will have it saved, and you can always go back to, but I haven't done it yet. No. Okay, so we need to save. But how are we assuming that one of these values is the head list? Right? What if we're not starting with A? I can't go backwards, nor can I find in memory anywhere that this might be associated. There is no variable that I can call upon to get to the A if I'm starting at B, right? I need to know what this variable is in order to assign it to B here, right? But I can't go backwards in this, like in doubly linked list. I'm learning how to choose the right. Okay, Siri, you're done. What do you guys think? I might be missing something, but I feel like I can't just pull out of memory what variable is attached to this because my node only has a data itself and a next value. Jake says, I don't think there's a way to do it without passing the full list as an input parameter. Yeah, that's exactly what I'm saying is I feel like either node X or Y has to be the head node, right? This isn't a doubly linked list where we have can go backwards or we have a header and a tailer or a trailer, right? This is, yeah. So we have to assume then, right? We have to assume that X node is given is the head node. so to speak. So we would have to, you have to give, so I put head here. Everywhere where I have node 1, I'll put head. So then you have to call this for node 1. I mean, that still didn't even work. So we're taking the head node, node 1. We're going down until we reach node 2. We set well, is current node happening on a local value here? Is this just keeping our current node here? Can you show where you set your head node? So we, given a head node, we're going to continually go down until we reach the other given arbitrary node in the linked list. Right? If we have some other condition within this loop, if the current node.next value is equal to none, we're going to return none, meaning that there's no node here, right? We're infinitely, right? Oh, so we're going to continue. So if we hey, Noob Coder, I appreciate you for coming in. Thanks so much for coming in. So I think that it's just keeping this here. So head.next. Wow. We're going to set uh, okay, so I appreciate you guys' help. I'm sorry if I am annoying you guys by struggling through this, but this is just the reality of this sometimes is it can be difficult. It's not always as easy as the previous problem was, right? So each problem is different and so um, so clearly our swap isn't taking place, which I think is because we are assigning things on a local level within our function, and then it's still so while current node dot next is not equal to node 2, we're going to Do I have to go like this and set this globally inside my function? Like that? No. If I set this global's not needed. Ah. So it's not something to do with my overall. I'm gonna print, I'm gonna go like this. I'm gonna take this guy. I'm gonna comment out here. I'm gonna take this guy, I'm gonna throw it here. I want it to print from 2 down. See what happens. I'm not calling it here. Ooh. I want to take this print. I want to call it here from 2 down. No. We don't want to call it here. I want to call it here. I want to see what our head is at this point. So I'm going to call that function. Node 4 is our head. So okay, perfect. So that's finding our node 4 and setting it our head. So our oh my gosh. Do I need to flip these too? So we're setting the current node.next, which is 4, equal to head. And we're printing it. So 4 is equal to head. When head, and then 4 gets set here for node 2. Okay. So that's what's going on. So sorry guys, I'm wrapping my head around this. We got the current node here dot next, which is housing node 4, because we have ran into our node 2 that's given, which happens to be node 4 in this function here. We are assigning node 4 to head. No, we don't want to do that. We want to assign the head value to node 4. Like that. So we're taking the current node, the one prior to our value, oh my gosh, this is tricky. So we have, I'm gonna make 1, 2, 3, 4, 5, none, right? We're wanting to start on node 1 go down until we reach here at this point. We're stopping here. We're breaking out. Current node is here. Current node dot next needs to equal the head value. Can you set that like that? Right? So now if we print that, we're getting node 1. And then we set node 2 not to head, but we need to save even if we save the value. So now one is being placed here, but we need to take the value of 4, which is current dot next, and save it as head. Oh my gosh. I feel like I'm right there, but I'm not. Okay, so we're appropriately setting, if I call print head here one more time, right before. Okay, so that's doing nothing. Work on a smaller list. Okay. Let's do the 3 per thing list. Let's do ABC. Right. Let's clear this out. A, B, C, none. Right? So we want to swap A and B. Okay? We want to swap A and B. We're going to immediately break out of our loop, and we know that we need to take head node 1, head, and node 2. We need to take our head node and set it equal to the place of current node dot next. Now without even looping, let's just set head node 2 is equal to node 2 head. Can we just swap variables like that? Now, this is N2. Okay, so that's not doing anything yet. So but we're not setting these placeholders. We need to set, this is going to be current node dot next next. Okay, now we get A there is still our head, which it shouldn't be. And the node 2 is so it's still in that order. Let me get rid of this and get rid of this. Oh my gosh, this is tough. It's probably, you guys are probably kicking at me here, but I'm sorry. Trying here. We need to save the equal to head. No, we need to save node 2 first as head, and then take the head right. So then if we say node 2 needs to be set first, final head, what's a node 2? Hey Abakar, thanks for coming in. I appreciate you so much for stopping by. Thanks so much for coming in. Okay, so we need to set the head.next value to just equal okay, so we have node 2 saved now. So we need to override the head. Oh. Cannot wrap my head around this one. Oh my gosh. Okay, so what do we need to do here? We have the head. Okay, let's say we're gonna swap B and A and C. We're gonna go, okay, no, we're gonna stop here. We're going to take B dot next and set it equal to A. So that will then fill in this value with A. We then need to take C or take A and set it equal to C. So we need to take the current node dot next is equal to the head node. Then we need to say that the head node No, because then this takes the value of head and assigns it to this value. We need to take the head value and assign it to this value of node 2. Oh boy. I don't know if this is right either. Current node next. Oh, hold on. So now we have an infinite loop going. So we're just assigning this. So this is just printing these two functions in this while loop over and over again. Oh, hold on. No, that still gives me the infinite loop. Oh my gosh. I'm not doing too hot on this one. All right, looping. Okay, so we've got an infinite loop going where? Obviously we have a loop going here and we have a loop going here. Things are being printed to the screen, so it's happening here. Oh, because there is no chain connected to the following value. So, right, that's what's happening, is that it's never getting to a none state here because I have a circular linked list happening here. So we're setting current node not next equal to head. I'm going to change this to later node, right? Just to have some more definition here. Later node. So we're going to set the current node dot next equal to the head. And then set the head equal to the later node. Now, this might work if I change this to 2. Now this just infinites me, prints me A. Oh my gosh, I'm struggling. It's okay, linked lists are not the easiest to understand at first. It takes time. The more you work with them, the better you'll get. Yeah, definitely. You guys are being nice to me for sure here. Okay, what am I missing here? Come on, I don't. It doesn't say that we're given the head. That's the difficult part. So I wouldn't ever be able to assign the prior value here to this place. Given references to only x and y, so these are is this assuming that these are next to each other or tangent to each other? Like x, y, z is assuming that x and y are next to each other, like a and b. Hmm. The relation of the second node needs to be linked to the head. At that position. Okay, so while current node while head does not equal the later node. So while the head node does not equal the later node, we're going to continually set the head node back head dot next until if head dot next is equal to none, oh my gosh, come on. Head dot next is equal to none, return none. Okay, let's continue. Thanks, Mo. I appreciate your kind words. You're so nice. You're swapping them but not updating their relations. So I'm assigning the current node dot next value equal to the head at that point, or now equal to temp, right? The temporary housing of the start, right? So I'm setting head dot next is equal to temp at this point. So we're going to traverse down this linked list. We have a head, we have a middle, and we have a tail. Okay, we're going to set the head place equal to temp as well, right? Cool. Temp gets saved here. We're going to traverse down until we get to a point where head if head while head dot next does not equal the later node. So we're going to stop here now. This is where we stop on our while loop. We're going to assign head dot next to the temporary value. And then take this value so we need to take this value though, later node, assigning the value of later node equal to head. Ugh, another infinite loop. Ugh. Oh my gosh, why is this so hard? So I'm only getting A here. Wow, head. I'm swapping them when I replace it there, but no updating the relation when I place it. What do you mean updating the relation between them? What do you mean by the relationship between them? Now, this is my first ever practice with linked lists. Is these questions here. We just finished the chapter a little bit ago, so this is all I've learned so far on your drawing. Oh, because head.next still has. Oh. Oh, so I need to set this value to temp.next. Dang it. I thought that would have done it. Ugh. So we need to set. So the later node.next. So the current node.next is going to be equal to the head, like that. We need to save the current node.next as a value and set that back Okay, hold on. We're getting mixed up here with all our variables. So we have head node, later node. We're going to say temporary variable is equal to head. We'll say saved or original head. is equal to this. While current node does not equal to current node dot next value does not equal to the later node, we're going to set current node equal to the current node dot next, right? We also need to set here the current node to start. So to start, we'll have current node. Okay, cool. We then will continue this loop until we reach the last place. Okay? Once we reach the last place, we need to set the current node dot next value we need to make sure that the temporary variable or original head corresponds to the next value Okay, so then we need to say, okay, gotta get out of this while loop. I think we're getting there, but slowly. As if we weren't slow already, you guys. Thank you for being here and bearing with me. Okay, so we need to save the current node at this point the current node dot next is our later node, right? The current node dot next is our later node. So we need to make sure that our later node dot next value is assigned back to head, is swapped entirely. So we need to make sure, take the head value, assign it to current node dot next, and assign then head dot next equal to current node dot next dot next. Oh my gosh. Okay, so we take the current node, we save it as we save a temp variable as current node, right? We then say that the current node dot next is equal to the header node. That takes our header temp or header or this is the OG head and places it inside this value here. We need to make sure that we retain head dot next is equal to temporary variable value, and then we need to make sure we retain that the temporary value dot next dot next or later node dot next, really, right? and then assign later node as our head? Or do we need to do that first? Oh my gosh, this is so tricky. Oh gosh. Temporary has changed by that time. So let's go back to our example here of head, middle, and tail. We are going to save OG head originally, right? We are then going to traverse down until we get to a current place where the next value is our given value of later node, right? Let's say we're wanting to remove the tail. So we need to save a couple of things. We need to save the value of current node.next, and we need to save the value of later node.next, or current node.next, right? So we need to save so this is the later node place holder, right? Is equal to current node.next. So we save the placeholder, and then we're going to assign the placeholder to head, which is right here. So we're right back where we started. Oh my gosh. I feel so dumb. I feel so dumb. Oh my gosh. This is the prompt here. Yeah. So we're starting on the head, and we're given some later node. Let me go ahead. So we have head, some later node, and then we have some tail that goes to node. In this example, we're going to start here on the head, and we save a value at this point of original head. Okay, we then traverse down until we reach a value. We stop right here in our while loop. Boom. N gets assigned as current node. The current node dot next value, the current node dot next needs to equal our OG head value. we need to then set the current node dot next equal to OG back it up. Okay, we save the current node dot next value. Let's just save these. Okay, let's just make these variables super explicit, I guess. Then let's try this. So we're going to break out of this loop, and we're currently at our m variable in our example. So our current node, which is our current node. So we need to save the left of the later node is equal to the current node. Current node dot next needs to equal, but I need to save first the value of it. So current node dot next, right, is equal to a temp value. Okay, we are then going to supply the current node value dot next is going to be replaced by the original head value, right? The original head value dot next needs to be replaced by the temporary value. So now we have successfully replaced our original head in for right here. So now this is OGH. We then need to take the later node and save it as our head value. Like that, I think. What is a hold and update? I've never heard of that before. Okay, so now what happens? What happens? We did something here. We changed the thing somehow. ABCAC. Oh no, what do we do? When you're updating next pointers, hold whatever you're changing it to so the naming conventions don't get complicated. I'm not sure what you mean by hold, though. I'm not sure what you mean by that one. Hold? Probably just missing it. Probably going over my head here. So, create a temporary variable. Connect A to C. So we have A, B, C. So C is being connected to A. which is then being connected to C. But we're trying to swap A and C. Oh my god. Oh, why is this so much more difficult than I thought? Back it up. So we're stopping here, okay, which is our current node. Our current node, this is our current node dot next, and this is our current node dot next dot next. Right, we need to save OG head right here. We need to save OG head right here. Meaning we need to override these values here. Right? So current node. So first off, is my while loop correct here? Let's see. At this point, I'm going to just print current node, right? Let's see what happens. I'm going to call this function here. Okay, A. A is our current node that we're on. ABC. Current, that's why current here. Okay, A is still our node here, which it should be B. We're trying, no, we're doing, so now if I change this to 3, this should give us B. Okay, good. So that's working. So we're trying to swap A and C now. So this is appropriately stopping there. Now, once we get to the current node, what do we want to do? Let's save temporary is equal to current node dot next. And let's print here temp, right? Boom, we should get node C now. Perfect. Right? So now node C is being captured here. We need to save current node dot next is now equal to the original head variable. So now if we print, but the original head dot next value needs to be the current node dot next dot next. So original head needs to be dot next variable needs to be set to the current node dot next or temp dot next, right? So right, perfect. So now we take current node dot next dot next dot next is equal to original head. Now we just put it in. Perfect. So now at this point, if we print current node dot next, Oh, hold on. Whoops. Not current node. Original head. It's temp next. Dot next. There we go. Like so. Cool. So now A is successfully put in for place C. Now if I do dot next here as well, this should be none. Perfect. Now I need to take my node C and replace it as head. So head now becomes equal to later node. And later node, but later node dot next needs to be equal to head dot next. Now if we print I think that'll work. I'm pretty sure. Now if I print head here, this should be C. Oh, I think we did it. I think we did it. Ah! I think we did it. Now head dot next, this should be B. None. Okay. Oh, there's so many variables you have to set. Oh my gosh. Okay. So head is equal to later node C. Head dot next is equal to oh, I just completely lost my place, my train here. Oh my gosh, no. Okay, so we have we take OG head, set the next value of it to temporary dot next. Now we just need to update the relation of head dot next to be what? Equal to the original head dot next. So we need to set this just that replaced. So now we need to set head dot next is equal to whatever the current head dot next is. Okay, so we need to say then that the so we need to say that we need to reserve the this is a oh my gosh, I'm so frustrated right now. It might not show it, but like I'm really kind of annoyed. Like I want to get this done. I'm ready. I'm ready to move on. Okay, so we are taking the current value next, saving a temporary value. I guess we don't even really need to save this as a temporary value, because we can just say current node.next.next. Right. And then we take the current node.next, set it to the original head. And now we need to save a value of original for original head.next though. Next is equal to the so let's just make a temp here, I guess. Original head.next. We set the original head is equal to current node.next. That puts that in. Okay. And then we need to take the temporary value that we assigned, which is original head next, keep it, but assign that head is equal to later node, and later node and later node and head dot next is equal to temp. Now if we print head here, this should be A, or C I mean, yeah. Okay, so now if we do head dot next, it's still none. I assigned head dot next to equal temp. Temp is original head dot next. Original head dot next equal to none, which was saved up here as none. So it needs to be B, which is the current node. Or the original head dot next. So let's just save this up here and just like that. Let's get rid of this temp variable here, and let's set the head next equal to just original head dot next, saved up here. So now if I print that, we should get B, exactly. So now if I remove my print statements, I think that's it. Oh my gosh. Let's call print singly linked list on N1. What? What? Oh my gosh, this is, oh, This is probably the worst stream ever. Sorry, guys. It's so bad. Oh, see, now if I print you my head here, at this point we get nodes C. Just wait until you get it. The satisfaction is crazy. I know. Right? It's gonna be like such an anticlimactic moment. All this. So, right, I print head here. Okay, so why isn't this working? Okay, I have it right. I have my nodes are correctly being swapped linked order, right? That is correct. C and A are being swapped. So why in this function call do I need to return head? I have it solved here. Like I have it solved. So something is just off with the way that we are handling either the printing. No, because this is starting off with A. So I'm printing N1, which is now my last element. Oh, where's the... But where is the none value now? We should have a none value, right? So the next of the... So it should be giving us a none value, though, for the last value in the chain, right? Oh, no, the while until we get none. Ah! Oh my gosh! Oh my gosh. Oh my gosh. That sucked. I just like feel so. I should feel accomplished, but I just feel so defeated. Oh my gosh. Well, I really appreciate you guys helping me out with this one. Oh my goodness. Oh gosh, that is so terrible. So terrible. I'm gonna do this. I'm gonna put into here. Um, Now what happens if I change this to N2 to try to swap those? N2 dot next is C. N1. Head is not my N1. Try with a bigger data set. Okay. Three. This is 4 D E F. Node 5. Node 4 next is equal to node 5. Node 6. 5 next. Node 6. Okay. So what if we want to swap node 1 and node 4, right? If we want to swap node 1 and node 4 becomes our new final value. Boom. Attribute error. While current node not next is not equal to none type has no attribute next. What did I screw up? Oh. Yeah. Yeah. Well, here we go. So N. Dot next is equal to n4, like that. Okay, so now if we run this, we wanted to swap 1 and 4. So A and D got swapped. Now if we want to swap 1 and 2, we got to print N2 here. Infinite loop. So why is it infinite looping if you have a value right next to one another? So, well, if it's right next to one another, then this immediately is broken. It's going to try to print the head data. So it's still printing B as our first value, which is true, but it's not getting to A. Another thing's broken here. My gosh, this problem is nuts. This one was so annoying. It's probably not even that hard for some of y'all, but I swear. Okay. I'm gonna move this down here. Like this. So why is it infinitely looping through B in our print statement? So what happens if I open these up? I remove this. Node B every single time. So it's not even happening in our loop here. Epic Freezer says you need to do an if check if one is next to the other. Oh, okay. So, pardon me. So where though is this loop happening? Like why is it happening? Because original head, it's taking in the original head, which is A in this case. It's going through, doing the swap. But where is the loop happening? It can't be in here. Oh my goodness. I need some caffeine here if we're gonna keep the stream going. Why are we getting B looped infinitely here? Whoever just subscribed, thank you so much for following along. I appreciate you so much. Um, why are we getting an infinite B loop here? Why is things being set to B? I want to check something. Let me go here and go Python loop debugger. Where's the step? Anyone have that thing? What is it called? That you can plug a loop into online and step by step walk through it. What is going on? So why can't we swap two values that are next to each other? If I did 3 here, and I did a print, did, what the heck? What the heck? Okay, that will do it for any other value. So then why is it taking place infinitely here? That's what I don't get. Is how is it being... So in our example here, let's clear out. We're going to start off on A and go into B. These are the inputs that were put in. So we're going to stop on our value here, current value, current node. We are setting original head to current node dot. Okay. So what's happening is, right, is that we are setting come on, stop doing that. Why? So we are setting the next value here. To the original head dot next. So the original head dot next is B. The current node dot next is A, B, C. So that's being set as original head dot next. But I'm not reusing this anywhere. Why am I calling this here? I'm creating this setting of a variable. Yeah, sorry guys. Oh, I need some caffeine. I need some caffeine. I'm gonna grab some after this problem. So let's rethink this problem then. if instead of, let's think about it from the standpoint of just two values in the list, right? So let's think about it from just two values in the list, in the linked list. We are saving, right, at this point, this while loop is already broken. We will not even enter this while loop because this condition is satisfied now, is no longer satisfied. The current node, which is A in this case, our head, which is also our head, right, is at this point, right? So we need to say current node dot next is a temporary value. Is a temporary value. Right? So we are saving this now as our temporary value. Okay? We then need to say that the current node dot next right? Or in this case, original head, but this is current node, so we need to deal with that. Current node dot next is going to equal, right? We need to set this. Current node next is equal to current node next. It needs to be set equal to the head provided. This head is going to have a dot next that needs to be set to the temporary value. Okay, so head dot next is equal to temp and current node dot next is going to be equal to head. Right? Now, if the okay, hold on. Actually, I think we don't even need to do all this. Sorry, you guys. We need to say if current node is equal to, right, our head, so if the current node is equal to the head, oh my gosh, this is so much like going on that I'm just, if the current node is equal to the head, meaning that there's only two values in the list, so the current node is at the head at this point, we just want to go ahead and swap the values of the two. So we need to make the the head of the B value. I'm like, been looking at this so long to the point where I'm starting to like not even remember what I did. Okay, I'm back. Back to dying here. This is so frustrating. Yeah, I'm trying to solve this linked list problem, Wise Coding. Thanks so much for coming in. Appreciate you. Um, I'm just really struggling. I cannot figure this out. So, move these down out of the way. So we have our node class here. We have a start. Hey Mahan, welcome. We need you here. I'm struggling through this one. I've been working on it for like over an hour here. I solved it, but I didn't quite solve an edge case to for when two numbers are next to each other. So it's just this is really annoying. I'm getting frustrated here. I want to do something else, but I don't want to give up. Appreciate you joining me here. Okay, so this is the problem we're doing. Assuming that the x and that you're given a head value. So we're going to say, while, current node does not equal to the later node, right? We're going to continually call dot next. So while the current node does not equal to the later node, we're going to continue call current node dot next. We are going to assign, just to start off, that current node is going to equal the head, right? So this is going to continually loop through and assign values or go until we get to one place before our later node. So that's the little bit the tricky part, Mahan, is that it's kind of the question is pretty vague. I think we've discovered that these questions need to be revised a little bit more, but it only tells us that we're given references only to x and y, and as a group we've kind of deduced down that you have to assume that X is the head, right? Because you wouldn't be able to get the previous reference without assuming that one of these values is the head, right? So while the current node does not equal the later node, we're going to continually loop through until we get one behind it, right? So in the case, all right. So in the case of A to B to C to none, if we wanted to swap A and C, we're going to go and stop right here. This is our stop, or our current node. Okay? But head is... Yeah, we could also have it so the function takes in 3 arguments, head, node 1, and node 2. Yeah. But head is STH. That is already saved in singly linked list. So we're swapping, we're only given, the thing is it says a singly linked list given references only to X and Y. So assuming that means that we're only giving parameters of X and Y. Something, okay. But we are unsure whether X or Y is the head of this singly linked list. And so I could not swap one of them in the middle, given like I had a list of A, B, C, D. I cannot swap elements B and D because I cannot traverse. I don't know if I didn't know the head. Right? So we have to have a starting place at the top of the linked list if we are encompassing all numbers. Right? Can you go to implementation you learned for singly linked lists? Here's your singly linked list here. Right here. Right. Linked stack. So this is all I have, whether it's empty, is empty. See, this is not like a doubly linked list where I can traverse back up and find a head via like a header. I'm in a singly linked list, not a doubly linked list, so I can't go backwards. I can only, if I are given a value that's arbitrarily in the middle, I can only traverse from that point forward. None of these functions, or the singly linked list, at least what is represented in this, did not give you any value or reference to the head node. I mean, you reference to the head node length, you have a def top, I guess, which returns the head element. But so yeah, you have a def top, right? Which I guess would reference that element top, right? Hmm. Okay, so we would have to then say you're given node X and you're given node Y, right? Current node start is equal to a head node, sorry, head is equal to top on node X, right? So if we give a top on node X, we set it to head. While current node, almost said this is the current node, right? Top. Cool. So this will traverse down until we reach a value of okay, so we need to we get a reference to the top is if this does not equal to node X. So while the current node does not equal to node X, we're going to continue to go down. Okay, we have met our node X, and what do we want to do? We're one before our node X. Well, we want to take one before our node X. We need to set temp X, right, variable is equal to temp X is equal to node X. I'm going to set node X dot next is going to be equal to set temp X dot next, right? That way I can keep this. So we set the temporary X variables not next equal to node X dot next. So I guess we just don't need this. And yeah, we do, because temp X needs to be saved here. We can't apply a method onto it without having a variable saved prior. I just keep getting lost in my mind. So we're stopping at B. We're saving our current variable to that. We're taking our temporary current node, which is previous to it. Our current node not at this point, our current node dot next value, right? Oh, we need a better example here. So we're trying to, if we have A, B, C, D, and none, and we want to swap elements B and D. We're starting at A. We're going to get to A. This loop is not going to be satisfied because we're already at this place where current.next. Got you. So we need to set the current node.next equal to the node underscore y, but we need to first set we had to like save all of these previous values in temporary variables as well. This is ridiculous. You have node X and node Y. The current node you're on is the top of node X. You're going to iterate down until you get one prior to node X. Let's say we want to, we want to swap values C and D for a better example. We're going to start on A. We're going to enter the while loop. We're going to go next, and we're going to stop right here. We need to set the value of B or current node dot next equal to D temporary variable or node Y. But we also need to capture the next variable of node X. So the current node dot next is set now to node Y. So now we have A to B to D, but D is still none, like so. So we need to set the value of current node we need to set the value of current node is B dot next is equal to node X given dot next, like so. So then, at this point, the current node next is now set to A, B, D, and what followed D. node X dot next, which was, in this case, was D. So that would not work. Oh my gosh, I hate this problem. This is ridiculous. Okay, so I can't define an example I like. We have A, B, C, none. Let's just do this. Let's say we want to swap we need a bigger set. We need a bigger set. A, B, C, D, E, F, and none. We want to swap C and E. Okay? We're going to start here. We're going to start here. We're going to go here and stop. We need to set current node dot next equal to node Y. Okay. We then need to set the current node dot next equal to no, we don't need to set current node dot next, or we could. It needs to be set to node X dot next, like we have here. So now the E is placed here. But we need okay, and the D stays. So now what happens if I print at this point? I want to print. I want to do node 3. I don't have a top function in this, so I'm just going to say head here, in here. I'm going to say head, right? I'm going to give it a head of N1. And then I want to go from N3, 5. I want to take node 5. Okay. Okay. So at this point, I want to print to the screen current node. Okay, I get node C. So our current node is node C. Node X was given as node 3, which is node C. Current node is equal to head well, current node does not equal node X. Current node equals current node dot X. Well, it does not equal node X. Well, node X given in this statement here, just close this. Node X is node 3, which is node C. So I should be getting node B back here. Why am I getting node C back here? What's the point? I'm missing a dot next here. Like that. I don't remember taking that out. I thought that was there the whole time. At least I had it there before. Okay. So we want to get one before now. Now we're at the B. Okay. So we want to save now. Okay, now what happens if I print here? Current node dot next. I get node E. So current node becomes E. Now what happens if I print current node dot next dot next? So this should give me F. Oop, dot next. This should give me F. Yes, perfect. Okay, so then if I back this up one more and print it here, this should give me now, I overrode that value. Now this should give me D. Yes. Okay. So now we have B, E, D taking place. Now we need to continually go forward in our loop and say, while current node dot next does not equal to node Y, we want to do the same thing as we did before, and then we're going to save the current node dot next is equal to node underscore X, and the current node dot next is equal to, now what would this need to be equal to? This needs to be equal to, we swapped E over, so this needs to remain the node Y dot next. So if I come here and I say, let's print the current node at this point, let's print the current node dot next at this point, and print the current node dot next at this point. What do we get? We get B, E, D, B, C, D. So while this will find an error, a bug no, because you're finding Y after editing SLL. So now we're staying on here. This should be DCF. EVD DCF. So then it's right current node. Hold on, let me back up here. Let me delete all these. What is current node at this point? Just B, okay? So if we're still at B, so at this point, what do we have? So at this point I have an infinite loop going. Ah, my gosh, I just hate this problem. So we need to save values, so we'll say I'm just not thinking that straight tonight, guys. If I'm being honest, I'm really struggling here. I'm disappointed in myself. Today was a rough stream. I really appreciate those that have been staying around and hanging out with me here. This has been pretty rough. I'm not gonna lie. This has been one of the harder streams that we've done. So what are the things that we need, right? If this is our linked list, A, B, C, D, E, F, right? And we want to swap the values of C and E. What do we need to do? Well, we need to save the values of C and E preemptively. So the current node dot next, so if we are on B, and we're wanting to swap C and E. We're currently on B, so this right here is B dot next is equal to node Y, which is going to be E, right? We then need to save, but we don't want to save it to node Y. We want to save node Y dot next value. Node Y is equal to temp Y. We want to set temp Y dot next equal to node Y dot next. So now we have a complete representation of this value, or copy, rather. We have a copy of node Y, but we don't want to set it to node Y dot next. We want to set it to node X dot next, because we want to have this be replaced. Then we need to do the same thing with the other values. So now we have temp X is equal to node X, and we have node, or temp X dot next is equal to node Y dot next. So now we've swapped C and E's next values for each other in these temporary values. And then we need to put, right, so we have node Y, temp Y. We establish that this temp Y next value is equal to node X's temp value, or node X's next value. So now successfully have an E value with the next value is D. So we need to take this and put it here. D through F through N. No, through E through F through N, right? Right. That will get plugged in right there. So now our array looks like this. Or hold on, we need to say, so not node Y, we want to make the current one next value equal to the temp Y, which is the E through D through E through F through none. And then we want to, and that'll take care of that. Now, we need so once we've done that swap, though, why don't you travel to find the previous node? Find previous nodes. Why don't you travel to find previous nodes of X and Y and do all at once? Okay. So then how come we need to travel to both of them? So how could we travel to both of them and save the information accordingly? So while the current node next value does not equal node x, we're going to save continually go down. And then say while current does this have to be within the while loop as well? While x previous. No, we'll say while current node dot next and make a universal variable before your current, say previous y and previous x, you found them too. So while the current node dot next does not equal node x, I'm so lost. So two while loops non-nested. So while this equals current node, while right? So we then want to set at this point val before x dot next is equal to the temp y value and the val before y dot next is equal to the temp x value. How does that look? So we're going to set the current node equal to the head. While current node dot next is not equal to node x, we're going to continually go down. In our example, we're going to stop on B if we're wanting to swap C and E. We're going to stop on B and then save that value of B as value before x. We are then going to loop again using that same value of B until we get to 1 before node Y. We're going to set current node at this point equal to value before Y. So we'll say we want to start from the beginning though. We'll say head here, right? So we'll start over from the beginning until we get to that place. So what's happening here? We have an initial array of, or a linked list, sorry, of A, B, C, D, E, and F. We are wanting to swap C and E. We're going to enter in, we're going to first establish a temporary Y variable, which is equal to node Y. So temp Y is equal to E, and then we set temp Y's next value to node X's next value of D, and D has a next value of E, and this has a next value of F, and this has a next value of none, right? We are then going to we're going to go through until we get to here, 1 before node X. We are going to save this value as val before X. We are going to then go through again until we get to here. We're going to set this value to val before Y. We are then going to set, we do also have a temp X variable that was created, which is equal to the value of node X, B, with a next value of node Y, so sorry, hold on, whoops, sorry. We have a temp X, which is equal to C, right? Which has a next value of node Y dot next, which is E next. Hold on. Temp X equals node X. Come on, you're getting this. You're there. You're almost there. So we're saving temp x of C is equal to C, and we're assigning the temp x next value is equal to node y dot next, which I don't think is correct. We don't want it to be equal to node y dot next. We want it to be equal to node but then why do we even have this then, is the question. So the y1, we're taking the value and we're assigning it here. So E needs to have D like it does, perfect. So then we need to take the E out and assign it from F forward. So the Y next. So we take C and it will have F through none, right? We're going to take that value and assign it to the value before X, next value, right here. But this should be I'm just getting wrapped up here. So we have a value before Y, which is D. D needs to go C, F, none. We are taking the value of C, duplicating it here, taking the next value and assigning it to the Y. Okay, perfect. Now value before X, oh my gosh. Coding Mountain Man, welcome up late with me here. Appreciate you joining me. Welcome back. This one's a struggle stream. Okay. Okay. So let's take these down, and we'll say we found these values. Well, what do we need to assign to these values? We need to assign to these values, right? We need to assign at this place specifically value before X, next value now becomes node Y. And this one would become node X. But the problem is node X's next value is node X's value is D. So that would become after this. So we need to assign node Y dot next is equal to node X dot next like that. Now what happens if I print head here? node A. If we call next on this, we get node B. If we call next on it again, node C, we call it again, F. Okay, so that's where that improper thing is being handled. So now if I come here and put it here and do the same print, perfect. So now if I run this, A, B, E, D, C, F. Ah, woo! Yes! Right? Now, the question is will this work if the nodes are right next to each other? No, it will not. Oh. All right, we're back. So this will not work if the nodes are right next to one another. Because the previous node is the node we want to swap, right? So we need to say, right, if at this point the current node is equal to node X, no, if current node, which is supposed to be 1 before X, if the current node dot next value is equal to the node Y, then we need to do something else. Hey Fartbag, welcome. Have you implemented the singly linked list ADT? You can learn a lot about pointers and node-based data structures. Yeah, this the book gave us the example of the data list ADT here for us. So if the current node's next value happens to equal at this point hold on, let's do it here actually. So we need to say at this point, after we loop through both of them, if the current node that is provided if the current node dot next is equal to node Y at this point, this would be node X rather, right? We're going to do the following. We're going to assign these, this means that they are right next to each other. So we need to assign current node oh my gosh. So if they're right next to each other, we need to swap those values. So we need to swap the data points, the references to one another, and the reference So if the current node's next value at this point is equal to node, no, because this would be one behind node Y, which would be node X. So if the current node, this is assuming that X comes before Y. Because can we do lines 34 and 35 in one line? Yeah, sure, probably, but it's not really crucial right now. We're trying to solve this other part. The current node, so in the case that we are right next to each other, right? In the case that we're wanting to swap D and E and they're right next to each other, we need to know one back, so we have the value before X already. We need to assign the value before X equal to Y, node Y, and make sure that node Y's next value is node value before X is equal to node Y. But we need to set the, but I don't understand why this doesn't work though. So what do we need to set? The current value we're on would be our X value, right? It is our X value. So we need to set the current node the value before X, which is the current node we're on. I'm struggling to wrap my head around this so bad. Well, I'm getting linked lists, but I'm just struggling with the coding aspect behind them and like making sure that everything is accounted for appropriately. So what happens in the case where we have two values next to each other, right? A to B to C to none, right? If we're wanting to swap B and C, well, we have a value before X. We have a value before Y as well. We have a current value or current node as well, right? So we could say if the values before X is equal to oh my gosh, I'm just defeated. So defeated. I really don't want to quit, but we've been doing this for a really long time. Hold on. I'm going to take this. I'm going to say, I have solved this problem for the case where X and Y are not next to each other. But I cannot figure how to go about it when they are side by side. Swapping two adjacent nodes x and y as a singly linked or doubly linked list requires some special handling because the order of pointers between the nodes is more interdependent. um, If you ever want to see a really nice little practice problem, check out NeetCode's SLL implementation. Okay, I'll have to check that out. Thank you so much for that recommendation. And they shouldn't be head, right? You don't have previous. So, right, we've got this solved for the case where these nodes are separated, right? We can also, right, that's the case. Now, will it also work if the node is N1 to swap with? And then we start off and we print node. Non-object next. So no, that wouldn't work either. So we've got it solved for this part. So let me just check this. Look at this is what I have. Your current implementation attempts to swap two nodes in a singly linked list, but there's some logical issues, especially when node X and node Y are adjacent. Issues in code. Finding the predecessor nodes. Your logic assumes you need to find predecessors for both nodes separately, which is unnecessary for adjacent nodes. If node X and Y are adjacent, finding value before Y, the predecessor of node Y, is redundant. Yeah. So in the case I want to do one while loop. I want to find the value of X, save that, and keep going until so what we'll say is, I just want to kind of take a stab at this tomorrow. This one is annoying. What is the next problem? I think your implementation works better with a dummy node as the header. What do you mean by that, Farbank? Not exactly sure what you meant by that. So 7.5 says implement a function that counts the number of nodes in a circularly linked list. Oh, I do not want to do that either. I haven't been this defeated since we first learned recursion. Oh, guys. So this is honestly, I'm glad that this is happening though. Like this, like and all, like no, I'm not glad it's happening, but this is good if we think about that. This is happening, right? This is just normal. This stuff does happen when you're learning programming, when you're learning anything, guitar, when you're learning, you know, whatever it is. This stuff is going to happen. Your while loop seems like it's trying to find the previous node, but with if node x is the head. Yeah, so what if node x is then? Yeah, but what if node x is the head? Exactly. So, like a little like an hour and a half ago, we refactored this. So initially, you guys, initially, I was assuming. So, I do think that this is a pretty poorly worded question because we don't know if we're supposed to be given a head value. We don't know if x is the head value. We don't know if x and y are, you know, or what order they're in, whether they come before one another. X comes before y or y comes before x. So there's a lot of like edge cases that are kind of being interpreted loosely here that I think are really causing us to struggle here. So I'm not totally attributing this up to our lack of ability to problem solve. I do think that this question is just pretty is isn't that greatly worded. What do you guys think? Do you guys think that this question just isn't that greatly worded? Isn't lacking context and detail? What do you guys think? Mahan, yeah, that's what I meant by and they shouldn't be ahead, right? Yeah. Yeah, I don't know. That's the question. I can't really answer that. I don't know. It's just the vague, ambiguity of the question, really. Oh, I feel just like I just feel just beat, just totally beat. Like I don't want to quit. Like I don't feel like quitting, but I just feel. Oh my gosh, this candle smells really good though. It's like very citrusy. Now, brewed tea. No, not brewed tea. This is called Learning Juice, Mighty Coca Cola. I probably need to get better at drinking more natural sources of caffeine, but I do have the soda tooth, unfortunately. I like soda a lot. Okay, guys, what do you guys think about this problem? Should we move on? Should we like should we just make a note saying like not all edge cases met um, question leaves room for interpretation, right? I'm not like satisfied with that answer. Like the problem solver in me is like just doesn't want to accept that that is what it is. like Osmond Gold. Hopefully not like that guy. That guy, he's got some cleanliness problems, I've heard. For handling a head case, we can say node X does not equal head and node Y does not equal head. In lines 33 and 34, even before the while loop. Yeah, that's what I was thinking. We could put it right here and say, if right node X does not equal head and node Y don't equal head, then go ahead and do the following. Right. Yeah. Okay, let's should we keep going here or should we work on something else? It's kind of late. It's already we're 4 hours into the stream, but I just feel like this was not very productive. We worked for 4 hours, but I honestly feel like I didn't get that much out of it. So I don't want to chalk it up to like a fail of a day, but oh man, going through it over here, guys. Let's see what any people in the Discord chatting it up at all. No, not really. Uh, because even if one is head, the other is has previous. Yeah. Okay. Um. Finish this. Well, what do we need to finish here? What is there to finish, really? I mean, we solved it for the most part. Like, it's just. So you could say, like, if node X does not equal the head and node Y does not equal head, we can do this following. So if node X does not equal head and node Y does not equal head, so both these have to be true for this to come true. For this to happen. Yeah, that's probably a good idea too. Let's take that. Let's take all this, put it back. Let's say here. So if node y does not equal head and node, we're going to do these, right? Else we're going to set, right? So if one of these is the header, so if, so if x does equal the header and y doesn't, then we're not, then we need to, so if x does equal the head and y doesn't, no, but this is, does not, these both need to be do not. Saying like this. Oh gosh, I'm sure I'm not even like really following along anymore. I'm kind of checking out here. It's getting late. So, but at what point would the values all right, I'm going to call it here. I'm just gassed. I'm honestly not even following along anymore. I'm pretty just beat. I need a break. I need to sleep here. But good news is though, you guys, I'm sorry my energy is low. I'm just really tired today. It's been a long week of, you know, like just a lot going on with New Year's and everything. Um, but tomorrow we'll take another stab at this. But I'm going to set aside some tomorrow in the stream to focus on continuing the Harvard CS50X course. So for those that don't know, that yesterday we started the Harvard CS50X course. Um, we are we started week 0 yesterday in Scratch. We watched the entire lecture in week 0, which was about a 2 hour long lecture. I recorded that stream from yesterday, and I'm going to be chopping it down and posting an actual just a physical video to the channel with just a more condensed version of that stream, just to make it a little bit quicker because I did talk to chat and pause a little bit. So Um, but tomorrow we're going to take a stab at the actual problem set 0 here. So I just want to take a preview here. What does it say? So, oh, so it doesn't really like us working on these. Collaboration on problem sets is not permitted except to the extent that you may ask classmates and others for help so long that it is not reduced to another doing your work for you. No, we are going to be doing the work entirely ourselves here live. But if you guys want to help as my classmates, then that's fine. But we're going to be doing our own work live. So I don't think that this applies to us. Download and install the latest version of Chrome. Submit starting from scratch. Oh boy. Okay, so this is what we're going to work on tomorrow. It's time to choose your own adventure. Assignment is quite simply to implement in Scratch at scratchmit.edu. Any project of your choice, may it be an interactive story, game, animation, or anything else, subject only to the following requirements. Your project must use at least 2 sprites, at least one of which must not be a cat. Your project must be at least 3 scripts total. Your project must use at least 1 conditional, at least 1 loop, and 1 variable. Your project must at least use 1 custom block. Your project should be more complex than most of those demonstrated in lecture. To meet these requirements, your project should probably use a few dozen puzzle pieces overall. Here's some inspiration. You can find tutorials and starter projects. Hello world. How to submit. Cool. So we've got to make a Scratch project tomorrow, basically. Now, I don't think it should be too hard. Scratch is fairly easy and fairly beginner, but it might be a little bit difficult kind of coming up with something to actually, implement. So again, guys, I'm really sorry that my energy was kind of lower for the back half of the stream. I just got really defeated by these couple of problems we were working on in data structures and algorithms. Um, but tomorrow morning, tomorrow I don't have work, so I'm going to be doing a double feature stream. I'm going to try to stream earlier in the day to help capture some of our international and East Coast audience, because I know a lot of my streams take place in the evening and in early mornings for them. So tomorrow morning I think around 10 a.m., I'm going to try to hop on and stream for at least 3 or 4 hours. And then I'll take a break for like lunch, and then I'm going to hop back on and do another part 2 double feature session. So I think in the morning time, we're going to take a stab at completing the project in Scratch. And then in the evening time, we'll go ahead and maybe either start another lecture up, or continue on with DSA and Python, or work on our independent small business manager project. I need to get better at kind of just setting hard cutoffs, maybe for switching between materials. I think a lot of people got bored here. I saw the view count kind of drop off pretty drastically as I went deeper and deeper into this rabbit hole. I do apologize for that. I know it can't be that entertaining to see me struggle through all this stuff, but sometimes that is just the reality of learning this and what it is. So, but I appreciate you guys joining me today. If you guys want, I might, if I'm gonna stay up and kind of hang out and watch some TV, I might jump into the Discord voice chat. Um, so if I see some people in there, I may jump in and say hello and see what's going on. But I'll see you guys tomorrow morning. I'll let an announcement in my Discord know about when I'll be coming live, probably around 10 a.m. PST. But yeah, join the Discord linked below if you want access to my study resources, like you see the books on my screen, my notes, as well as follow my GitHub to get access to all of these repos that I'm doing. I'm pushing these all to GitHub for you guys to also use. And please subscribe and follow along to the channel if you enjoy. Again, I'm sorry for the grind that we did today, the rabbit hole we dove down, but we're going to be continuing with CS50X tomorrow. And I'll see you